This is TechSNAP, episode 423, for February 21st, 2020. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm joined by Jim.
What's up, everybody?
Since we last met, Jim, Ubuntu's had another release on 18.04. Yeah, that's right, it's 18.04.4. Now, normally, while I appreciate these patch releases, I don't give them too much thought, but a recent article of yours over at ours made me think I should probably be appreciating these more than I am.
This was an unusually big maintenance release, in my opinion. There were a ton of new features and backports in there. You know, everybody's favorite Amazon web launcher goes away.
Finally.
More importantly, for those of you who are toiling along under Windows boxes for your daily drivers, there's a pretty big improvement there now. If you've got X11 and or Pulse Audio instances running on your Windows host, you know, like from MOBA Xterm or the Win32 Pulse Audio that freedesktop.org links to, Ubuntu 18.04.4 will now automatically recognize those and configure the Linux subsystem to route your video and graphics through them.
Wow, that's fancy. I mean, we've come a long way for context. When WSL first launched, you could get these things to work, but it really felt like a hack. This seems like it might be almost seamless.
Yeah, pretty much. I think there's still going to be an awful lot of people that don't know about like Windows X11 servers or what the best one to run is. And it's unfortunately a very difficult Google. You usually end up, getting led through like Sigwin and I can't remember the name of it, but there's another one that gets recommended pretty frequently. Xming, that's it. That's very, very, very out of date. But MOBA Xterm is by far the best one, in my opinion, if you need to do that kind of thing. It's an SSH client utility, and it has the X server built into it, and it's modern and updated and very easy. Now, the Pulse Audio on Windows, I don't actually know anything about that. I hadn't even heard that there was such a thing until I was looking through the release notes for 18.04.4.
All these improvements make me pretty glad we see these maintenance releases. I mean, not only are they very predictable, but at the same time, it means you can stay on a stable base of software, but still see some improvements. You're not stuck on what you had when it launched forever.
Over at ours, I did that Linux on laptops little mini review of what it was like trying to get Linux going on an HP Dragonfly Elite laptop. And it would have been a somewhat different review if it had just been, like 2 weeks later when I did it, because as it was, 18.04.3 didn't have a new enough kernel to detect, I believe it was the wireless card. It had a very bleeding edge Intel Wi-Fi chipset.
It's always the Wi-Fi.
Well, it's usually the Wi-Fi. But, in that case, I just installed 1910 and it was fine. But as you know, I prefer to stick on the long-term support releases when I can. And now with 18.04.4, that's another change, is that, I would have been able to do that just fine. Just enable the hardware enablement kernel and everything would work flawlessly.
If you haven't already, now is a great time to upgrade. We'll also have links to everything like MOBA Xterm at techsnap.system/423. Well, 18.04 is all well and good, but if you've been watching the benchmarks over at Phoronix, you'll have probably noticed another distribution that is, frankly, spanking it in some benchmarks. Jim, you recently had some time to try out Intel's Clear Linux as a daily driver and had some interesting thoughts.
I don't think there's any question that if you're wanting to get the biggest numbers out of your benchmarking, you want to do it under Clear. And to be completely fair to Intel, right up at the top, where Clear Linux really is well suited is when you've got a fairly, tightly well-defined task that you repeat over and over and over again, like a 3D render farm or something. In which case, it's almost certainly going to be worth your while to get that environment built on Clear and running there to, get potentially a 10 to 20% performance boost. As far as for a daily driver, though, they've made a lot of progress, but I would say it's definitely not ready and not worth the hassle.
For those not super familiar with Clear, it's Intel's own Linux distribution with some optimizations they claim have good results.
And they absolutely do have good results. The problem, again, is that what Clear is really optimized for is long-running computational and storage-related workloads. What it's not optimized for is the kind of low latency, respond to the click that you just made really quick that you're looking for out of a desktop system.
That's where we come back to something like the right tool for the right job. Clear Linux does have some interesting things, though. I mean, it has its own package management system. What did you think of that?
I'm not quite sure what to say about that because Intel's messaging on the technology behind Clear hasn't been entirely clear, in my opinion. I watched a lot of their videos and read some of their documentation about the things that they had done. But in their own promotional materials, they don't really talk about speed as much as they talk about security and stability. And honestly, it sounded like they were describing Debian. So I didn't really get a lot of value out of that material. And I was left to just kind of try to draw my own conclusions about it. So I'm not sure if they needed their own package manager or not to achieve their goals, or if it was literally just a case of not invented here syndrome. Clear's package manager is something called swapd, software update daemon, I would presume. And it works, but it's wordy. The arguments are very odd on it. Rather than doing a swapd install or a swapd add to install a new package, instead you have to do swapd bundle-add. And when you want to look for info on a package, it's swapd bundle-info. It's unnecessary. It's not like there's some other kind of add or some other kind of info that needs the differentiation, and it's very easy to flub it. Like in Ubuntu, when Ubuntu added the apt-add repository command, they quickly found out that a lot of people were typoing that as apt repository add instead, and so they added a symlink. So either way you typed it, it would work. There's nothing like that going on in swapd. If you mess up and you type swapd add bundle, it just doesn't work. If you swapd add, it just doesn't work. You gotta get bundle add out the gate. And more importantly, I found that the indexing packages for use with the search functionality of swapd doesn't always work quite right either. If you swapd search a particular package with keywords that absolutely should bring up the package you want, it might find them or it might not. And even more damningly, if you swapd file-search for a file that's included within a package, it will not always provide you with all the packages that incorporate that file.
There are some aspects that interest me as they write their documentation. Versioning happens at the individual file level. This means Clear Linux generates an entirely new OS version with any set of software changes to the system, including software downgrades or removals. This is kind of similar to the model that Git uses for internal version tracking, where any of the individual file commits move the pointer forward. But that comparison to Git seems apt from your description. Seems like Clear Linux's tools, perhaps sound under the hood and trying some new models. They just don't have the nice porcelain on top that a user actually wants day to day.
Right now, it's got a lot more warts than I would really expect out of a daily driver, and I didn't see enough benefits to come with them to make it worth putting up with that. Most of us who are big-time open source enthusiasts and have been for a long time, clearly we're willing to put up with a certain amount of warts compared to the most polished, consumer-friendly, yada, yada, yada. But we are because we expect to get real benefits out of that. And again, if you're building a render farm or some other setup that, it's got a very, very tightly controlled workload that's very repetitive and does the same thing over and over again, it's probably worth your while to look into building that on Clear. But if you've got to do a much wider, more general purpose desktop, or even in my opinion, server, you're probably rapidly going to spend more time dealing with warts than you're getting back out of the optimization.
Okay, well, server use cases are, definitely something we might consider with Clear Linux. I assume that means you tried installing ZFS.
Well, of course I tried installing ZFS. Spoiler alert, I managed to make it work, but it really wasn't easy. It was a lot more difficult than it would have been on any other distribution I can think of. There was no package for ZFS for Clear Linux, and I'm not going to blame that on Clear, although they did respond negatively to some user requests to build, a swapd package for ZFS. Whatever. They didn't want to deal with the license. I get it. I'm not going to hammer them for that. But building the source on Clear was difficult.
Not just the regular amount of difficult that building from source can always be, right? I mean, at least when you're on Ubuntu or Fedora, there's some packages you have to install first. That's done. They probably already figured that out for you, and you run make and configure and build the modules. I assume that was a little more difficult in Clear.
It was considerably more difficult. The building the source tarball for ZFS is just like it would be for about anything else. You download the tarball, you extract it, you change into the directory, you do a /configure, and then you do a make install. And, if it's a good day, then that's it. You're done, right?
Yes, the make gods are smiling on you.
Yeah. But one of the things that will frequently happen if you're trying to do this with ZFS particularly is if you haven't installed a particular dev package on Fedora, I want to say that's uid-devel, and on Ubuntu, it's, I think, libuid-dev. Now, the source tarball for ZFS assumes a Red Hat-like environment, so if it doesn't find the header file for uid, uid.h, then it's going to complain you need to install uid-devel, the Fedora or CentOS package name. So obviously, if you're on, that, call it a flagship, distro for ZFS on Linux, then you literally just yum install that thing and you're done, right? On Ubuntu, you got to do a little bit more searching because the package names don't quite match. Now, instead of uid-devel, you end up finding libuid-dev. But basically, you do an apt search for uid and pipe it through to grep dev, and you found it. It's not difficult. On the other hand, if you do a swapd search uid, you will absolutely get quite a few returns, but none of them will be the package you need. And as you look through that, then you might say, okay, well, I see that swapd has the swapd file-search option, like apt file search. I can search for all packages that include a particular file name. And you know that you're looking for uid.h because that's what the configure script complained about not being able to find. So you say swapd file-search uid.h. And now you get like 3 pages of package returns, and none of them are the one that you're actually looking for.
Okay, now this is getting pretty frustrated, and I'm probably pulling at my hair.
I very definitely was. There's a GitHub issue in Clear's Git tracker where a user had asked about a swapd ZFS bundle and had been denied. And in Clear's own FAQ, they linked to that closed, deprecated issue as an answer to whether you can have ZFS or not. And so, I'm kind of looking through these prior users' travails, and they talk about some not entirely documented steps you have to go through to enable out-of-tree signing, and I bash my way through that, and I get a couple other packages installed, and I switched from the native kernel to the long-term support kernel, which was a journey, and that also involved some bugginess in Clear. Not all the arguments, the very basic arguments for Clear's boot manager, they don't all work. So that wasn't fun, but I eventually got through all that crap, but now I'm stuck with the uid.h thing. And the users who had built ZFS before no longer remembered what they'd done because they'd long since moved away from Clear.
Right, you get it working and then don't document it, and who knows? Then
I opened up a new issue on the ZFS on Linux project, and I chatted a little bit with Brian Behlendorf, and he was like, I don't know. I've never tried to get this working on Clear, and I don't know anything about it. And we kind of chatted about, what I had tried, and I said, well, can you tell me where the configure script is looking for uid.h? Maybe I can monkey patch it because I've got that file on the system. It's just obviously not where the configure script is looking for it. And he's like, no. There's several different kinds of uid.h, and the one that you found is one for a kernel interface, not for this libuid package that we're looking for a header for. And he mentioned something about the a libc64. I was like, oh, well, that gives me something else I can try. So I start looking for a libc64 package and get nowhere on that either. But one of the other things that he had said, literally when he's just trying to explain to me why the uid.h that I found on the system wasn't the one that I needed, he mentioned that, what we're actually looking for here is the header associated with libuid.so.1. And then I was like, oh, wait a minute. Okay, so what happens if I do a swapd file search for libuid.so.1 for, the actual shared object that we're looking for the header file that interfaces to it? Now I come up with hits. Now I've got libuid.so.1 is provided both by OS Core, which is installed, and by OS Core dev, which is not. And of course, usually when you tack dev onto the end of a package name, that means now you get your header files. And sure enough, when I do a swapd bundle add os-core-dev. It downloads about a gig worth of crap and installs it, and now my .configure runs flawlessly.
Well, that is quite a journey, and if you didn't understand all the details of what Jim just described, maybe Clear Linux isn't quite ready for you. I am curious, though, Jim, was there anything that surprised you that you enjoyed about Clear?
I enjoy how incredibly bleeding edge the native kernel is, even though that probably wouldn't have worked with ZFS. And I don't know, it might have. The OpenZFS project says that it only supports kernels up to 5.4, but I don't know if they literally just haven't updated that, to look at 5.5 yet. It might have built flawlessly. I don't know. I didn't really try.
I've got some disappointing news there. As of this week, 5.5 is not quite ready yet. There's another GPL symbol workaround that's needed.
Great.
Yes, I use Arch, and this is why I know.
By the way, Wes uses Arch.
That's right.
I also appreciate that, most of the packages are very new in there. So I don't know. I would absolutely consider Clear Linux OS for a software build farm or a graphics render farm or, a cluster of machines that are running saturated all the time where you'll really see a big benefit out of 10 to 15% performance improvement. And it doesn't much matter what living in it from day to day is like because it's just doing the job that you set it to do. I think it's very well suited for that. For a desktop daily driver, there's honestly not anything there that would make me say, yeah, I want to do that. With that said, I do want to make clear also that when I say there's nothing there that would make me want to use it for a daily driver, you should absolutely append the words right now to that. This is still a very actively developed distribution. And for all I know, in a year, maybe 6 months from now, maybe the Intel engineers will focus really hard on the desktop and just the general usage experience, and it could turn into an amazing distro. But right now, nah.
Something else we always keep our eyes on is, of course, ZFS. Sounds like there's an interesting proposed improvement that might be coming to our favorite file system sometime soon.
Yeah, this is one that I've been hoping for years now. It really, really surprised me when I found out that wasn't a thing to begin with. For those of you who are familiar with L2ARC, it's a special type of VDEV that is frequently thought of as an SSD read cache, most typically going to be used for a pool full of Rust disks. So the idea is, you can have the best of both worlds with slow but great honking big and cheap Rust disks and small and super fast but somewhat expensive solid state disks. So you store the majority of your data on the Rust, but you have this transparent read cache in front, and so data that you access a lot you can get at solid state disk speed. The unfortunate thing here is that the L2ARC is not persistent. You would think that once you've filled an L2ARC SSD, that if you reboot your system, you still have a nice hot cache on the solid-state disk, but you actually don't. When you reboot the system, your L2ARC is effectively empty, and it begins to fill from scratch all over again.
We've talked about the ARC before, the adaptive replacement cache. How does that work together if you do enable an L2ARC?
So L2ARC just stands for Layer 2 ARC device, and it's a little misleading, even apart from the lack of persistence. You would think that the L2ARC is just going to be a bigger space that the ARC can expand into as it needs to, but that's not actually the case. The ARC is, of course, in memory, like any other file system cache would be. And, if you're not immediately familiar, the big difference between the ARC and a more typical file system cache is, I like to say you can think of it as a weighted cache. The more frequently you access any given block, the heavier it gets and the harder to displace out of memory it becomes. As you do actually come up with more blocks to cache than you have ARC available to fit them in, if you have a Layer 2 ARC device, then when they get evicted from the ARC, they'll actually get stored in the L2 ARC. And now if a block has been evicted from ARC, but it's available on L2 ARC, you can read it from there, and you still don't have to go down to the metal on your main storage.
Right, you just hit that fast SSD, and you don't have to wait for the main array to actually go fetch that data.
But with that said, L2 ARC is not actually ARC at all. It's a ring buffer. As more data gets evicted from the ARC, It pushes whatever is in the L2 arc out towards the edge, and it really doesn't matter how many times something has been read in L2 arc. It's just a ring buffer. It gets pushed out by new data coming in. There's nothing special about it.
All right, well, there's clearly some tricks to getting this all configured right. Was not having persistence really that big of a deal?
The better question, Wes, is having an L2 arc actually that big of a deal? You know, you're never going to get the kind of hit rates out of L2 arc that you do out of primary arc, both because it is a lower layer and you have to actually have evicted blocks out of the arc to get them to L2 arc to begin with. So these are clearly not going to be your most valuable blocks. Then you add on top of that the fact that because of the nature of the L2 arc, because it's not in RAM, it is on actual storage, whether it's, you know, a solid state disk or not, it becomes a lot more expensive to constantly reorganize that. And so it is just a ring buffer, not another arc. The big question is, did you need that at all? And the answer for most people is no, you absolutely don't. Most people, if they install an L2 arc VDEV, they see practically nothing for hit rates out of it, and they get really frustrated about that, and they say, why doesn't this work? And the answer isn't that it doesn't work. It's the answer is really more that the arc works extremely freaking well. The last bit of, you know, where it actually becomes useful is this idea, well, I can have maybe a big L2 arc and, you know, it's always there. And I've got, even if it's not a high hit rate, there's a relatively large amount of data I can move off of this thing because it is so much bigger. So I am avoiding going back to main storage. And in a lot of senses, that's also kind of a misconception because they're just not that valuable. But the final nail in the coffin for L2 arc, as it stands right now, is that lack of persistence. For that data to be really valuable, I think it has to persist across reboots. It has to offer you the security that you say, hey, if I reboot my system, I'm not going to completely cold cache state. That's going to be helpful for me whether I'm, you know, doing a desktop system or even if I'm using like a massively loaded database system. I've worked with database-backed websites that were completely inoperable for up to half an hour after a reboot because you needed to manually warm the caches before exposing them, you know, to the flood of users. If you just dumped the user on the database with all caches cold, because there was so much traffic, you'd end up with deadlocks and it would never be able to warm the caches and it would never be able to serve the users. You'd have to have this like manual procedure. Now, having a persistent L2 arc could go a long way to nerf a lot of that. But I think it's probably going to change my recommendation as to, you know, should you bother with an L2 arc? If you have an extra SSD lying around, which up until now, my answer has just been no. Just don't bother. There's got to be a better use you can have for that. But with persistence, maybe now it starts looking more compelling.
Well, that's certainly something to look forward to. As you said, it's not yet merged, but from looking over at GitHub, seems like it's already got some approval from project leads.
Yeah, Brian has said that he likes it. He's signed off on it. It's been a few days since I've looked over there, but last I checked, Brian was looking for another senior developer to QA the code and sign off on it, and then they were looking for a merge sometime in the next couple weeks. Now, as always, I do want to remind listeners that when I say they're looking for a merge in a couple of weeks, I'm talking about a merge to master, and it's going to be, you know, a few months after something shows up in the master tree before it may actually show up in a release. And then beyond that, if you're not installing ZFS manually yourself by downloading it from the ZFS on Linux project, then you're looking for your distribution to actually package it, and that may take a little while also.
Software, it's complicated, but at the end of the day, ZFS is great.
All right, Wes, that's enough about ZFS for now. Stop. Hammer time.
Yes, it is HAMR time, or at least just about. No, we're not talking about MC Hammer. We're actually talking about Seagate.
Well, and not just Seagate. We're talking about several hard drive manufacturers, and specifically, we are talking about laser-assisted hard drives. Pew, pew, pew.
Anytime there's lasers involved, I mean, it just gotta be better, right, Jim?
Well, you know, one would hope so. I will say, it's kind of surprising how many places lasers cropped up. That's not something I would have really expected as an 80s kid. It's one thing to say, okay, so, you know, now we have CD-ROMs and then DVDs and Blu-rays and whatever optical discs that are read or, you know, burned, written to by lasers. That makes sense. But it kind of blows my mind seeing lasers in places like if you've bought a record player, like for old school vinyl LPs anytime in the last 5 to 10 years, it's probably had a freaking laser on it.
Lasers What can't you do?
Lightsabers, unfortunately. Can't make a lightsaber out of a laser.
These changes are needed because one thing all these vendors agree on is the obsolescence of non-energy assisted magnetic recording. And this is because of the magnetic recording trilemma. Yeah, a fun name, but it just means we're kind of at our limits. You need whatever medium you're writing to be resistant to changes in magnetization because you want stability. You don't want your data to change out from under you. But you also need those write heads to be able to overcome the resistance to change in order to actually write a change to the medium. But the smaller the individual grains on that medium, the smaller the magnetic field your head can generate to change it without overlap and changing something next door. And therefore, the weaker that field must get. That's tricky to get right.
And so that brings us right back to zap it with a laser. When you heat up the magnetic medium, it becomes a lot more pervious to change, so it's easier to alter the magnetic state of that very small spot that you heated up really rapidly, really hot. And so you zap it with a laser and heat it up, and you use your right head to make the change, and then it cools down. It becomes relatively impervious again.
Very clever. Now, Seagate in particular has been talking about these for a long time, but they're actually trialing 16 terabyte versions right now with some select customers, and they claim they're plug-and-play replacements for traditional drives. You seem a little skeptical about that, though, Jim.
I have to be. I would be anyway. I'm especially skeptical given that it's Seagate, and there's an awful lot of people who have tried to use Seagate's shingled magnetic recording SMR drives as just drop-in replacements for standard hard drives and rapidly been very, very upset about it. Shingled magnetic recording drives are extremely slow to write, and so they usually feature a non-shingled write area of the disk that's used as a write buffer for incoming writes. And then, kind of behind the scenes, it can sort of stream these out to the main shingled area of the drive. But if you overflow that write buffer, things get down to I won't say dial-up speeds writing to the disks, but I will say fractional T1, if you remember back in, those evil days in the late 90s.
Try to forget.
Yeah, kilobytes per second, which absolutely nobody is looking for. And, also, it's hard to say ahead of time how many of these HAMR disks are also going to be shingled. We know that a lot of the larger design plans do involve both shingled magnetic recording and, heat-assisted magnetic recording. And so you would expect that pretty much to devolve to the worst case out of those technologies. But at the same time, not every HAMR disk has to be SMR. I feel like there's probably going to be a middle ground where, you'll have disks that are somewhere in the say 10 to 15 terabyte range, over the next year or two that will be HAMR but not SMR. And those hopefully really will be drop-in replacements. But we won't know for sure until we actually get a few on hand and test them.
Well, if lasers weren't enough, Western Digital has been working on some technology, this one called MAMR, microwave-assisted magnetic recording.
From the end user's perspective, it's basically the same crap. You're still just heating up a small portion of the drive in order to make it writable and then letting it cool to become unwritable again. It's just using microwaves instead of lasers. And Western Digital has been really hot and heavy on the MAMR technology for a while. They have patents on both MAMR and HAMR, but they've been leaning towards the MAMR stuff. The only thing we know for sure is it looks like basically everybody at this point agrees you're going to have to get your hard drive hot to write it. Personally, I'm really hoping for BAMR, blowtorch-assisted magnetic recording.
It's a cruder approach, but boy, those densities are great.
Looks good in the case with the big clear vinyl window.
Well, that hopeful look at the future of storage technology brings us to the end of this episode of TechSNAP. But don't worry, there's a whole lot more over at techsnap.systems. There you'll find our entire back catalog, show notes for this and every other episode, and easy ways to get in touch. If you'd like more Jupiter Broadcasting content, just head on over to jupiterbroadcasting.com. And if you haven't already, check out Linux Headlines, all the Linux, open source, and cloud news you need in 3 minutes or less. If you'd like more Jim, well, he's writing over at Ars Technica, and he's also on Twitter. Jim, you're
at JRSSNet.
I'm there too. I'm at Wes Payne. Thank you so much for joining us.
We'll see you in a couple weeks, everybody.